Hello friends, welcome to my YouTube channel, Raja Gogasikotar 1719. What if I told you something exists in the universe, so powerful that nothing, not even light, can escape it? A cosmic mystery that has baffled scientists for over a century. Welcome to the mysterious world of black holes. What is a black hole? Imagine a place in the universe where the laws of reality begin to break. A place where gravity is so powerful that even light, the fastest thing in existence, cannot escape. This place is called a black hole. Despite its name, a black hole is not an empty hole or a tunnel in space. It is an object with extreme mass compressed into an incredibly small area. So dense, so powerful, that it bends space and time itself. To understand this, think of gravity like a stretched fabric. When you place something heavy on it, the fabric curves. Now imagine placing something so heavy that the fabric tears inward endlessly. That distortion is what creates a black hole. At the heart of every black hole lies a region called the Singularity, a point where all known laws of physics collapse. Here, space becomes infinitely small, and gravity becomes infinitely strong. Surrounding the black hole is a boundary known as the event horizon. This is the point of no return. Once anything crosses this invisible edge, there is absolutely no way back. Not even light, not even time. From the outside, black holes appear silent and invisible, but their influence can be felt across entire galaxies. They control the movement of stars, shape the structure of galaxies, and may even hold clues to how the universe itself was born. For decades, black holes existed only as mathematical predictions. Many scientists believed they were impossible, too strange, too extreme. But the universe had other plans. And as we move forward in this documentary, you will discover how these cosmic monsters are born, what happens when something falls into them, and why black holes may be the key to unlocking the deepest secrets of reality itself. 2. The birth of a black hole. Every black hole has a beginning, but its birth is not gentle. It is violent, explosive, and terrifyingly powerful. To understand how a black hole is born, we must first look at the life of a star. Stars are not eternal. They survive because of a delicate balance, an endless war between two forces. Gravity pulls the star inward, while nuclear energy pushes outward. For millions, sometimes billions of years, these two forces remain perfectly balanced. But one day, the fuel runs out. When a massive star exhausts its nuclear fuel, the outward pressure suddenly disappears. Gravity wins. In a fraction of a second, the star collapses under its own weight. This collapse triggers one of the most powerful explosions in the universe, a supernova. For a brief moment, the star shines brighter than an entire galaxy. But when the explosion fades, what remains is something far more dangerous. If the core of the collapsed star is massive enough, nothing can stop the collapse. Not heat, not pressure, not even the laws of physics as we know them. The core continues to shrink, smaller and smaller, denser and denser, until gravity becomes so intense that space itself caves inward. At that moment, a black hole is born. There are also black holes created in another way, when two dead stars called neutron stars spiral into each other. Their collision releases enormous energy, and the combined mass collapses into a single black hole. And then there are the giant supermassive black holes. These monsters live at the centers of galaxies. They are millions to billions of times more massive than our sun. No one knows exactly how they form. Some believe they were born alongside the universe itself. One thing is certain: black holes are not rare cosmic accidents. They are a natural result of the universe's most extreme forces. And now that we know how they are born, the next question becomes even more disturbing. What happens when something gets too close? 3. What happens near a black hole? Approaching a black hole is not like approaching any other object in the universe. There is no warning sound, no visible barrier. Only an invisible force growing stronger with every passing second. From far away, a black hole appears calm and silent. But as you get closer, gravity begins to take control. At first, you may not feel anything unusual, but slowly, space itself starts to stretch. Time begins to behave differently. According to Einstein's theory of relativity, the stronger the gravity, the slower time moves. Near a black hole, this effect becomes extreme. To an outside observer, you would appear to slow down, freeze, and never quite reach the edge. But for you, time would feel normal until it suddenly doesn't. As gravity increases, your body would begin to stretch. Feet pulled harder than your head. Atoms pulled apart in opposite directions. Scientists call this terrifying process spaghettification. Every object, no matter how strong, is eventually torn apart, thread by thread. As you approach the event horizon, the point of no return light itself bends backward. The universe behind you distorts and disappears. Once you cross that invisible boundary, all known paths lead inward. No signals can escape. No messages can be sent. No information returns. Inside the black hole, our understanding of physics breaks down completely. Space and time collapse into something unrecognizable. Some theories suggest that time stops. Others propose that it reverses. And some even suggest that crossing the event horizon may lead to another universe entirely. But the truth is, no one knows. Everything beyond the event horizon remains hidden, forever sealed from the outside universe. And this leads us to the greatest mystery of all. What lies at the center of a black hole? 4. Inside the black hole. The singularity. Beyond the event horizon, there is no return and no certainty. This is the region where every rule we know begins to fail. At the very center of a black hole, scientists believe there exists something called the singularity. The singularity is not a place in the normal sense. It has no size, no shape, no direction. It is a point where matter is crushed to infinite density and gravity becomes infinitely strong. Here, space collapses completely. Time loses meaning. Cause and effect may no longer exist. The equations of physics give up at this point. Einstein's relativity predicts infinity, a sign that the theory itself is incomplete. Inside the singularity, distance becomes zero. Time may stop, or perhaps flow in a direction we cannot imagine. Some theories suggest that everything falling into a black hole is compressed into this single point forever. Others suggest something far more radical. What if the singularity is not an ending, but a beginning? Some physicists believe black holes may give birth to new universes hidden from ours, connected through space-time in ways we do not yet understand. Others propose the existence of wormholes, bridges connecting distant parts of the universe, or even entirely different realities. But there is the problem: information. According to quantum physics, information can never be destroyed, yet black holes appear to erase everything that enters them. This contradiction is known as the black hole information paradoxon of the greatest unsolved problems in modern physics. Does information disappear forever? Or is it somehow preserved at the edge of the black hole? No experiment has ever answered this question, because no one and nothing has ever returned from inside a black hole to tell the story. And as we move forward, scientists will attempt the impossible, to study something that cannot be seen, cannot be touched, and cannot be escaped. 5. How scientists detect black holes. Black holes are completely invisible. They emit no light. They reflect nothing. So how do we know they exist at all? The answer is simple. We don't see the black hole itself. We see what it does to everything around it. The first clue comes from motion. Stars near an invisible object sometimes move at incredible speeds, orbiting something massive that cannot be seen. Only an object with extreme gravity could force stars to behave this way. And when nothing visible is there, scientists know a black hole is up hiding. The second clue comes from light, ironically, from light that is being destroyed. As gas and dust fall toward a black hole, they do not disappear immediately. They spiral inward, faster and faster, heating up to millions of degrees. Before crossing the point of no return, this superheated matter releases powerful radiation, especially X-rays. By detecting these invisible X-rays from space, scientists can map the presence of a black hole with astonishing accuracy. But the universe offers scientists something even more extraordinary: ripples in space itself. When massive black holes collide, they shake the very fabric of reality. These vibrations, called gravitational waves, travel across the universe at the speed of light. For the first time in human history, we have instruments sensitive enough to feel these cosmic tremors. These waves carry the unmistakable signature of black holes merging, a silent confirmation of their existence. And then came a historic breakthrough. Humanity captured the first image of a black hole's shadow. Not the black hole itself, but the dark silhouette it casts against glowing matter. A direct glimpse of the unimaginable. Through motion, radiation, and ripples in space-time, black holes revealed themselves, not as myths, not as equations, but as real physical objects shaping the destiny of the universe. And yet, even after detecting them, one mystery remains. What role do black holes play in the future of the cosmos itself? 6. The first photograph of a black hole. For more than 100 years, black holes existed only in equations and imagination. They were invisible, untouchable, unprovable to the human eye. Many believed we would never truly see one. Then, in 2019, everything changed. Scientists announced something once thought impossible: the first ever image of a black hole. Not a photograph in the traditional sense, but a shadow. A dark silhouette surrounded by a ring of blazing light. This image was not captured by a single telescope. It required an entire planet working together. A global network of radio telescopes spanning continents and oceans functioned as one Earth-sized instrument. Together, they formed the Event Horizon Telescope. For years, massive amounts of data were collected. So much information that it could not even be sent over the internet. Hard drives were physically flown across the world. When the data was finally combined, a haunting image emerged. a black hole located in the galaxy M87, over 50 million light-years away. The glowing ring revealed matter being heated to extreme temperatures just before vanishing forever. At the center, the shadow, the outline of the event horizon itself. This image was more than a scientific achievement. It was proof. Proof that Einstein's predictions were correct. Proof that black holes are real. And proof that humanity can observe the most extreme objects in the known universe. For the first time, we were no longer imagining black holes. We were witnessing them. But this historic image was not the end of the story. It was the beginning of a new era, an era where black holes are no longer hidden. And as technology advances, the universe prepares to reveal even deeper secrets. Secrets that may change everything we think we know about space, time, and reality itself. 7. The unsolved mysteries of black holes. Even after photographing a black hole, humanity is still standing at the edge of the unknown. Black holes answer some questions, but they create far more than they solve. The greatest mystery begins with a simple question: what happens to information inside a black hole? According to the laws of quantum physics, information can never be destroyed. Every particle, every detail, every state must be preserved. But black holes appear to erase everything. Once something crosses the event horizon, all information about it seems to vanish forever. This contradiction is known as the black hole information paradox, a problem so deep that it challenges the foundations of physics itself. Some scientists believe information is stored on the surface of the event horizon, encoded like data on a cosmic hard drive. Others suggest information slowly leaks out through a process called Hawking radiation, a faint glow predicted by physicist Stephen Hawking. This radiation implies something even more shocking. Black holes are not eternal. Over unimaginable spans of time, they slowly lose energy, shrink, and eventually evaporate. But if a black hole disappears, what happens to everything it consumes? No one knows. Another mystery lies beyond the singularity. Some theories propose that black holes may be connected to white holes objects that cannot be entered, only exited. Others suggest black holes are gateways, connecting distant regions of space-time, or even creating new universes. There is also a question that borders on philosophy. Do black holes mark the end of reality, or the boundary of our understanding? Are they cosmic destroyers, or cosmic creators? Every theory brings us closer to the truth, yet every answer reveals how little we truly know. And perhaps that is the greatest mystery of all. Black holes are not just objects in space. They are challenges forcing humanity to rethink the nature of existence. And as long as they remain, the universe will continue to whisper secrets we are still learning how to hear. 8 black holes and the fate of the universe. Black holes are not just cosmic mysteries. They are architects of the universe itself. At the centers of galaxies, supermassive black holes quietly shape everything around them. They control the movement of billions of stars, regulate the birth of new suns, and determine the structure of entire galaxies. Without black holes, the universe might look completely different. As galaxies evolve, black holes grow, feeding on gas, dust, and even other black holes. With every merger, they become more powerful. But their influence does not last forever. Over incomprehensible spans of time, black holes slowly fade. Through Hawking radiation, they lose energy, evaporating particle by particle. Trillions upon trillions of years from now, even the largest black holes may vanish. And when the final black hole disappears, the universe will enter its darkest era. No stars, no light, only cold, empty space. This possible future is known as heat-death, a universe stretched thin, silent, and still. Yet some theories suggest another ending. What if black holes do not destroy the universe, but recycle it? What if the collapse inside a black hole triggers the birth of something new? A new universe, a new beginning. If this is true, then every black hole could be a cosmic seed, ending one reality while creating another. In this view, black holes are not symbols of destruction, but agents of renewal. They remind us that the universe is not static. It evolves, transforms, reinvents itself. And perhaps, long after our universe fades, something else will rise from its shadows. Something born in the heart of a black hole. 9. The future of black hole research. For centuries, black holes were impossible to observe. They existed only in equations and imagination. Today, they are becoming laboratories for the future of science. With new telescopes, more sensitive detectors, and advanced artificial intelligence, humanity is preparing to explore black holes like never before. Next-generation observatories will capture sharper images of event horizons, revealing how matter behaves at the edge of reality itself. Gravitational wave detectors will listen deeper into the universe, catching the echoes of black holes colliding billions of years ago. These signals will allow scientists to test the limits of Einstein's theories and possibly uncover new laws of physics. Some researchers believe black holes hold the key to unifying quantum mechanics and gravity, the two great pillars of modern science that refuse to work together. If that puzzle is solved, it could rewrite our understanding of space, time, and the origin of the universe. There is also a growing question, not of science, but of possibility. Could black holes one day be used as energy sources, as gateways for exploration, or as natural clocks, measuring the deepest flow of time? These ideas remain theoretical, but every major breakthrough was once considered impossible. Black holes force humanity to look beyond comfort, beyond certainty, and beyond the limits of imagination. They remind us that the universe is far stranger and more beautiful than we ever expected. And as we continue to explore these cosmic giants, we are not just learning about black holes. We are learning what it truly means to be human in an infinite universe. 10. Beyond the darkness. Final conclusion. At the edge of the universe, there are places where light ends, where time bends, and where human understanding begins to fail. Black holes exist in that darkness. They are born from dying stars, grow at the hearts of galaxies, and shape the destiny of the cosmos. Once feared as cosmic destroyers, black holes have become guides revealing how space, time, and gravity truly work. They challenge our greatest theories. They expose the limits of our knowledge, and they force us to ask questions that reach beyond science itself. What is reality made of? Where does time truly flow? Is the universe finite or endless? Every black hole is a reminder that the universe is not built for simplicity. It is built for mystery. Yet even in the deepest darkness, human curiosity shines. From equations written on paper to telescopes spanning the Earth, we have dared to look into the abyss, and the abyss has answered. Not with fear, but with wonder. Black holes tell us that endings and beginnings may be the same thing, that destruction can give rise to creation, and that the unknown is not something to fear. It is something to explore. As we stand on a small planet orbiting an ordinary star in a vast and ancient universe, black holes remind us of one truth. The universe is far bigger than us, but our curiosity is bigger still. And as long as we keep asking questions, the darkness will never truly be empty, because within it lies the future of discovery. So friends, this was today's amazing information. Hope you liked this video and learned something new. If you found the video interesting, don't forget to like, share, and subscribe. See you again in the next video with another new and surprising thing. Until then, stay happy, stay healthy, and stay tuned to learn. Jai Goga Sikatar Ma.